Hello everyone, you are welcome to the Dawn's Consult, where chemistry is highly simplified. As I had in my last video, where I started treating past questions on JAMB, because some of you requested that we should start preparing for JAMB. Alright, so here comes another question from UME 2002. If you look at this question, the question is on electrolysis. The question says, what amount of mercury would be liberated if the same quantity of electricity that liberates 0.65 grams of zinc is applied? What amount of mercury would be liberated if the same quantity of electricity that liberates 0.65 grams of zinc is applied? And you are given options: 2.01, B 1.00 grams, C 4.02 grams, and D 8.04 grams. Now, how do you solve this kind of problem? Firstly, you must understand that the quantity of electricity that you used to find the mass of mercury that was liberated was the same as used in the liberation of 0.65 grams of zinc. So therefore, you need to find the quantity of electricity that was used to liberate that 0.56 gram of zinc. So how do I go about that? Using a very simplified method. Those of you that have followed my previous video on calculations, I try to use a methods that will not warrant you cramming formulae in your head. Okay, so now what do? You have to write the cathodic equation first. And how do I go about that? Zinc is 2 plus, and that will give you 2 minus. You already know that, right? So if I'm to give it like this, it's going to give me zinc. All right, so that means there are 2 electrons here, and most times electron represent Faradays. That is 2 Faradays, and that's equivalent to 2 times 96,500 coulombs. You know that 1 Faraday is 96,500, and these 2 now represent this. All right, so if I'm going to solve this now, that will be you know that 2 times 96,500, that should be around 193,000 coulombs, if I'm correct. Okay, you can clarify that with your calculator. All right, so that means 193,000 coulombs actually liberate the mass of zinc. What is mass of zinc? You are not given the question, but you should. These are some of the things you should know often. Mass of zinc is 65 grams. So that means 65 grams of zinc. That means 193,000 coulombs of electricity liberate. That's the expression of this equation. I'm expressing this equation now, that 2 of this liberate 65 grams of this. Is that right? So now, therefore, what coulomb will liberate 0.65 gram of zinc? All right, what coulomb will liberate 0.65 coulomb of zinc? So mathematically, I can cross multiply, and my x will be equals to 193,000 times 0.65 all over 65. All right, okay, if you punch with your calculator, which I'm going to do now. All right, if you punch, okay, that will give us 1,930 coulombs. 1,930 coulombs. That means 1,930 coulombs was the quantity of electricity used to liberate 0.65 gram of zinc. And they say, what amount of mercury will this quantity liberate? Now, the next thing you are going to do is to write the cathodic equation of mercury. Mind you, mercury has this Hg, and of course it's 1 plus. That means 1 electron here to give us the mercury state. All right, that means this is 1 Faraday. All right, that means 1 Faraday liberates this. Now, another thing you must put to your mind is, what is the mass of mercury? Mass of mercury is 201. So that means 96,500 coulombs of electricity liberate what? 201 gram of mercury. Are you getting it now? That's the expression of this equation. Okay, now what mass will this 1,930 column liberate? That's what the question is asking us. What mass of mercury will this liberate? So if I have this and I cross multiply, my x will be equals to 1930 times 201 all over 96500. Is that right? So when I have this and I punch with my calculator, or yeah, punch, let's do that. Okay, when I punch, okay, that gives me 4.02 grams of mercury. 4.02 grams of mercury. So that means, according to the question asking me what amount of mercury would liberate the same quantity of what amount of mercury would be liberated if the same quantity of electricity that liberates 0.65 grams. So what mass of mercury will be liberated using that is 4.02, and in the options, that's option C. So C is the correct answer. That's how simple chemistry can be. Stay tuned, stay glued to this channel. If you have not subscribed, please do. If you are coming across this channel for the first time, I can promise you that this is the right place to be. We'll bring you more questions, simplified solutions, and make you ready for your exams. We follow to see that you get nothing less than distinction. That's our goal, our vision. You can read our statements on the on our profile there and know what we stand for. That's the Don's consult for you, and I wish you the very best. Thank you. See you when I come again with a very interesting package.